So most of us have probably heard that term quantum mechanics before, or maybe quantum physics, but where does that term come from? What does it mean? Other than sounding really cool and scary and mysterious and difficult, where does that term come from? Find out today on Quantum Basically. So the word quantum has to do with this concept called quantization. Quantization is the idea that there is a smallest piece of something. For instance, matter. You probably learned in, 8th grade science or something like that, that there's a smallest piece of matter. Maybe you learned it was the atom, maybe you broke it down further and learned about protons and neutrons and electrons. But whatever the case is, you know that you can't have half of an electron. You can have a whole electron, but you can't have a half of one. It literally doesn't exist. That's the idea of quantization, the idea of a smallest piece. Quantum mechanics, we study which things are quantized. That is, which things there are a smallest piece of. For instance, is there a smallest piece of length? You can imagine that if the meter was the smallest length, you could travel a meter, or 2 meters, or 3 meters, but you could never travel a half a meter. Now, we know that the meter can't be the smallest length, because obviously we have lengths that are shorter than that. But it turns out length is also quantized. We have this length called the Planck Length, or sometimes pronounced the Planck Length. Is there a smallest piece of time? I mean, the smallest piece we measure on everyday scales is the second, but things can last a half a second, or a millionth of a second, or a billionth of a second, or a billionth of a billionth of a second. Is there a smallest piece of time? Well, as far as we can tell, yes. It's called Planck time or Planck time. But in quantum mechanics, often what we're talking about when we talk about quantization is energy. You might have seen a diagram like this if you ever took a chemistry class. Maybe your teacher told you that an electron can have this energy or this energy, but cannot have that energy. I don't think that one's too weird. It's just the idea that electrons have to gain energy in discrete amounts. That's fine. But then it gets a little bit weirder because then we start talking about positions. This would be a model of an atom where you'd see the nucleus here and the electron either in this orbit or in this orbit. In this model, you could think of an electron being here or here, but it cannot be here. Now, I used to play this version of dodgeball when I was in elementary school, and the coach would tell us, you're either in this region or you're in this region. Can you be in this region? No, you can't hang out there, but of course if you're traveling from here to here, you gotta pass that area, right? So of course when your teacher says that an electron can't be here, they have to mean that they can't be there for very long, right? Not in this case. In this case, what they're saying is it literally can never, ever, ever be here, which means that an electron will transition from being here to here instantaneously. And now you're going, wait, KM, this is a problem, right? 0 time, but traveling some distance? Maybe some of you who know some things about speed are saying, I don't think electrons can travel faster than light. I don't think anything can. So what's going on here? Well, they're not exactly going faster than light. In fact, this model is pretty incomplete, and I would say completely wrong. It's a good way to think about things when you're just starting out in middle school. But if we want to take things to the next level, we're going to have to think a little bit deeper. Well, the answers in quantum are rarely straightforward, but the first clue can be found in the form of a cat. That's right, Schrodinger's cat, which we will talk about next week. If you want to catch next week's Quantum Basically, subscribe to this channel. There will be other videos between now and then, but the next video for this will come out next Tuesday. See you then.